So please allow me to introduce our course project Net Music to you. The project is a website that provides music-related web service, including music searching, music-related social chatting, and music recommendation. The website is implemented through Django framework, and to implement this specific function, including chat or recommendation, we have several different kinds of dependencies, and for convenience, we have write all those dependencies into the requirements.txt file. So if you want to run our project on your own computer, you first need to install all those dependencies on your computer according to the requirements file. Now let's get started. So as you can see, this is our home page. So if you click the Start Searching, you will jump to the login page, and for demo purpose, we have a demo account. After we log in, we will go to the search music page, and here is a keyword search. You can type the keywords, and our search engine will tell you the related music. So for example, if I type the cat and click the Start Searching, now we will get several search results, and those images are randomly generalized since we didn't store any posters in our database, and randomly choose one. Click that, we will jump to its detailed information page of that music. And for every music, we may have some comments. For demo purpose, we have randomly write some comments, sure comments. So these are for demo, so their contents may not strictly related to the music. And we can also see the user profile page that will show the related information about the current user. And here you can see all your friends, or we can see followers. And you can see all your followers' recent comments on some musics. And now let us go to the chat page. So to implement web chat with friends, simply query data from the database is not enough. The implementation of the chat function is based on Django channels, which is based on WebSocket and very widely used now. So WebSocket is a new protocol that provides a persistent and open connection between the client and the server, with either able to send data at any time. So for example, type the hello, and so and finally, the most important part is the music recommendation part. So for the music recommendation algorithm, we implement a KNN algorithm to find the best possible music a user may like. So for each user, the feature for the KNN algorithm are the all music in the database. Then we can calculate the distance between one user and all the other ones, and select the top k neighbors. Then their favorite music are possible choices for the current user, since they may share a large amount of interest, and it's very likely that the user will also like the recommended new music. However, there is a problem in the above approach. That is, there are too many music in the database. So the dimension of the fixtures may be too large and will make the performance very bad. So to improve its efficiency, instead of brute force CAN algorithm approach with some improvement that will help us improve the efficiency. So for each user, we will only consider the music he has tried before. And when calculating the distance, we only consider the users who have listened to at least one of the music as well. So for example, if user A has listened X, Y, and Z, we will search all users who have also listened X, Y, or Z. And when calculating the distance, we only use X, Y, and Z as a fixture, since they are the major parts which really makes the result different. So that's the framework of our recommendation algorithm. And now we can click the get recommendation. Since the recommendation results are okay, you can see the calculated results, and we recommended 8 music for the current user. So that's all for our project. Thank you for your listening.